So we have this question here that says find the inverse of this matrix that we have there. So then to find the inverse, first things first, we need to find the determinant of the matrix. So the determinant of this matrix, we have 1, 3, -2, -1, -5, 6, 2 there, 6, -3 like this. So we're going to use the first row here. So this is positive, negative, positive like this. So this will be equal to 1 there. Then we have -5, 6, 6, -3 here, minus 3, we have -1, 6, 2, -3 like this. Then plus -2 here, we have -1, -5, 2, and 6. Okay, so now here we find the determinant of these 2 by 2 matrices and we add them all together. So here we have -5 times -3, we get 15, minus here we have 36 there. And here we have -3 there. -1 times -2, we get 3. Then 2 times 6, we get -12 there. Plus -2. Then here, -1 times -6, we get -6. Or -1 times 6, we get -6. Then 2 times -5, we get -10. Then minus, we're going to have plus 10 there. So then here we have 26 here, or 21 rather, -21. Then there we have -27, because this -3 minus 12 we get, 3 minus 12 we get -9. -9 times 3 we get +27 there. Okay, so then here plus here we're going to get a 4. 4 times -2, we get -8 there. So then we add everything together here. We're going to have -29 plus 27, which will give us -2 as our determinant there. Okay, so now after finding the determinant there, we have to find the matrix of cofactors. So now to get the matrix of cofactors here, let's just scroll down a bit. We go to the next page here, so we write cofactors there. Then we're going to use this matrix here: positive, negative, positive, negative, positive, negative, positive, negative, positive, like this here. So now the first 2 by 2 matrix that we're going to have there, we know that this is going to be positive there. We have -5, 6, 6 here, and -3. We close there, minus the next matrix there is going to be -1, 6, 2, and -3. We close. Then this one here is positive. We have -1, -5, 2, 6 here. We close there. Okay. Okay, so here, this matrix that we're going to have there is going to be negative. So then there we have a 3, negative 2, 6, and negative 3. The next one is going to be positive. We have 1, negative 2, 2, and negative 3. Then this one here is negative. Then we have 1, 3, 2, and 6 there. Then here we know that it's going to be positive. We have 3, negative 2, negative 5, and 6 here. Then here, negative there, we have 1, negative 2, negative 1, and a 6 there. Then this one here, we know that it's going to be positive. Then we have 1, 3, negative 1, and 5 there. So here, so negative 5 times negative 3, we get 15, minus 36, we get negative 21 here. Then here, negative 1 times negative 3, we get 3, minus 12, we get negative 9 times negative there, we're going to have positive 9. Then here, negative 1 times 6, we're going to get negative 6, negative 6 plus 10, we're going to get a 4 there. We can close like this. Then here, 3 times negative 3, we get negative 9. Negative 9 plus 12, we get 3. Then 3 times the negative outside here, we're going to have negative 3 here. Like this. So then here, 1 times negative 3, we get negative 3. Negative 3 plus 4, we get 1 here. Then here, 1 times 6, we get a 6. 2 times 3, we get a 6 there. 6 minus 6, we get a 0 there. So then here, 3 times 6, we get 18. 18 minus 10, we have 8 here. Then here, 1 times 6, we get 6 there. Minus 2, we have a 4. Times a negative here, we have negative 4 like this here. So then here, 1 times 5, we get a 5. Plus 3, we have 5 plus 3, we have 8 this side. Okay. Okay, so this is supposed to be a negative 5 here. So let me just put a negative there. So we have a negative 5 there. So now 1 times negative 5, we get a negative 5. Plus 3, we get a negative 2 here, like this. So then now here, what we're going to do now here, since this is a matrix of cofactors that we have, then the adjoint of this matrix here, the adjoint is just the transpose of the matrix of cofactors that we have here. So the adjoint is simply equal to the transpose of this matrix that we have. So the rows become columns and the columns become rows. So we have negative 21, 9, 4, negative 3, 1, 0 here. Then we have 8, negative 4, and negative 2 like this here. So now, remember to say the inverse of a matrix is simply equal to 1 over the determinant multiplied by its adjoint. So then here, we not say we have our determinant 1 over negative 2. The inverse of a matrix is just 1 over the determinant here multiplied by its adjoint there. So you have 1 over the determinant there multiplied by the adjoint. So here we're just going to have negative 1 over 2 we get the adjoint, we write it here. We have negative 21, negative 3, 8 there. We have a 9. Let me just write it nicely. Okay, so here we have a 9, 1, negative 4 here. Then we have a 4, 0, and a negative 2 like this. So this here is the inverse of the matrix that we're looking at there.